Good afternoon. It's me, Mr. Werger. Sorry I'm not with you in class this afternoon. I had a friend from high school that unfortunately passed away from cancer, and so I'm at his memorial service this afternoon. Please put your phones away, and hope I can have your undivided attention for this short video. We are starting chapter 9 today, brand new unit, and today's lesson is on what's called the Pythagorean theorem. Pythagorean theorem is one of the most well-known theorems in all of geometry. Most people that you talk to that have taken geometry, if you say Pythagorean theorem, they're going to know what that is. Something that is very common and you will use a lot this semester and when you take future math classes. For warm-up, I'd like us to work on these 4 examples. So you're solving for x. And remember your order of operations. There's several exponents in these problems, so exponents come before addition or subtraction, right? Okay, so I'm going to ask the subject pause on the video for about 5 minutes. Work through these 4 examples, please. Okay, let's see how we did here. So squaring something, multiplying it by itself. 4 squared is 4 times 4, that's 16. 3 times 3 is 9, equals x squared. So then we can combine like terms here. We can add 16 plus 9 is 25. To get rid of a square, we take the square root. Square root cancels out a square. So I will take the square root of both sides, and we'll get x equals 5. The square root is a number that when you multiply it by itself, gives you this number. So when we take the square root of 25, we're finding what times what equals 25. And the answer is 5 times 5 is 25. So the answer is 5. If there's any questions on that, hit pause on the video because obviously I'm not here to answer your questions. But the sub could probably clarify that for you, or maybe a classmate can explain it in a different way. Otherwise, we'll move on to the next example. So 13 squared, 13 times 13, 169, plus x squared. 25 squared, 25 times 25, is 625. Okay, so here we have a number and we have x squared together on the left side of the equation. So we want to get the x squared by itself, like it was in the last example, before we take the square root. So we can subtract 169. That cancels that out. So then I would have x squared equals 456. Okay, and then we get out our calculator for that one. So on my calculator, I do the square root button first. And a lot of times the square root button is right above the x squared button on your calculator. So we hit a shift or a second button first, and then what is above that is what's happening. So there's my square root sign. Square root of 456. Okay, and I got the decimal there, so let's round to the nearest tenth. So about 21.4. Go at 21.4. You can see a little better over here. Square root of 456, 21.35. So if that hundredths place is 5 or higher, we round up. This is closer to 21.4 than it is 21.3. Okay, so we took the square root. Square root. X. And then I'm going to use the approximately equal to symbol, which is like a wavy equal sign, to say that it's not exactly 21.4. It's approximately 21.4. But I did round. It's actually 21.35, whatever. But we're going to call that 21.4. Okay, next one. So this is the square root of 5 squared. So I'd like you to be able to do that without a calculator. But just to show you what it is with a calculator, the square root of 5 squared. Square root of 5 squared is 5. Okay? And that shouldn't come as a huge surprise because we just saw this with x, right? When we take the square root of a square, the square and the square root cancel each other out, and we just get x. Okay, so that's the same thing that's happening here. The square root and the square are just canceling each other out. So you just get 5. 5 plus x squared. 12 times 12 is 144. So again, here we would subtract. We're subtracting 5. So that'd be 139. Take the square root. Second square root 139. And again, if I round to the nearest tenth, so I've got 11.78. So that's closer to 11.8. To 11.7, so we'll say approximately 11.8. X is approximately 11.8. Okay, so let's see if we can do this without a calculator. So when we square the square root of 10, we should get 10. And then we're also squaring 5. So this whole thing is being taken to the second power. So we need to do 5 times 5, which is 25. And then this is 25 times 10, 250. The square root of 2 squared is just 2. Okay, so here these numbers are on the same side of the equation. Combine like terms, 248. And then take the square root. Square root of 248. 15.74. So that's closer to 15.7 than it is 15.8. So we'll go 15.7. Okay, again, you can hit pause if we need to discuss that further. But we will be making calculations like this for all of our Pythagorean theorem problems. Okay, so let's talk about the Pythagorean theorem. So we use this with right triangles. It only works with right triangles. So it's not a right triangle, this doesn't work. So use only with right triangles. And we know it's a right triangle. If we've got the little box in the corner, that means that's a 90-degree angle. So this is a right triangle. The side across from the right angle, that side has a name. That's called the hypotenuse. H-Y, pi, P-O, hypa, T-E-N, 10, hypotenuse. U-S-E, hypotenuse. The hypotenuse is always across from the right angle. Anything else you know about the hypotenuse of a right triangle? Did anyone say it's the longest side? The hypotenuse will always be the longest side. Okay. Then the other two sides are called legs. Okay, so with the Pythagorean theorem, we call the legs A and B, and the hypotenuse is C. A and B are the legs, the hypotenuse is C. So then the Pythagorean theorem is not a super complicated formula. A squared plus B squared equals C squared. That's the Pythagorean theorem. A squared plus B squared equals C squared. Okay? So let's try an example. Find the length of the hypotenuse. So here we have a right triangle. The hypotenuse is the side across from the right angle. So that's C. The other two sides are the legs. And it doesn't matter. So I'm going to call this one A and this one B. But it really doesn't matter which you call which. You could switch those around and that would be okay. But it's essential that the hypotenuse is C. That's the one that always has to be C. Okay, so if I do A squared, so if A is 8, then I would do 8 squared plus B squared, so B is 6, so 6 squared equals C squared. So I put 8 in for A, I put 6 in for B. And now this is very similar to one of the first equations we talked about, right? So do 8 times 8, 8 to the second power, that's 64. 6 times 6 is 36. add those two numbers together. 64 plus 36 is 100. And then that's c squared. So we get rid of that exponent by taking the square root. And what times what equals 100? Hope someone got 10. 10 times 10 is 100, right? Okay, so the hypotenuse of that right triangle is 10. Okay? So I hope that makes sense. Example 2. Find the length of the missing side. Okay, so is this missing side, is that the hypotenuse or is that a leg? Remember, the hypotenuse is always across from the right angle. So in this case, the hypotenuse is 13. And one of the legs, so we need to find the other leg. Okay, so we still use a squared plus b squared equals c squared. So a squared would be 25 plus b squared. We don't know what b is in this problem, that's what we're finding. Equals c squared. C is 13. Okay, so square the numbers that you have there. 5 times 5 is 25. 13 times 13 is 169. Okay, so then here we want to do some subtraction first before we take the square root. You want the squared part to be by itself before you take the square root. So subtract 25. Move that up a little bit. So b squared equals 144. Take the square root. And the square root of 144 is 12. So that missing side is 12. Okay, so then let's flip over to the back side. Okay, so here you're given the three sides of a triangle. And the question is this a right triangle? So it doesn't have the little box there telling us it's a right triangle. We need to use some math to determine yes or no, is it or not. Okay, so if it's a right triangle, then a squared plus b squared should equal c squared, right? If a squared plus b squared is not equal to c squared, then it's not a right triangle. Okay, so we're going to check to see if a squared plus b squared equals c squared. And remember that c squared is the hypotenuse, that's the longest side. So I got to get my side lengths in the right positions in the Pythagorean theorem. 4 times the square root of 5. Should we just quickly check and see what that's equal to? 4 times the about 8.9. Okay, so I checked that just to make sure I knew. So if this is a right triangle, then 12 is going to be the hypotenuse. That's the longest side. This is only 8.9, that's 8. Okay, so I'm going to make A 8, B 4 times the square root of 5, and C is 12. So Pythagorean theorem, 8 squared plus 4 times the square root of 5 squared equals 12 squared. A squared plus B squared equals C squared. And now I'm checking to see if this is true. So 8 times 8 is 64. If we square the square root of 5, that's 5. 4 squared is 16. 16 times 5, I'm pretty sure is 80. 16 times 5 is 80. Or I could have put 4 times the square root of 5 in parentheses and squared that. Oops. That was wrong. I did division instead of multiplication. 4 times the square root of 5 parentheses squared. Let's try that. Okay, and I did get 80 that way too. Okay, so I've got 64 plus 80. 12 times 12 is 144. 64 plus 80 is 144. So I get 144 equals 144. So my answer is yes. This is a right triangle. If these had not been equal, if one side had been 140, something that's not 144, then my answer would be no, it's not. Okay. This is just a list of what are called Pythagorean triples. So these are side lengths that do make right triangles. So we saw 6, 8, and 10. We saw that in a previous example. What else did we see in a previous example? Here's 3, 4, 5. 3, 4, 5. Here's 6, 8, 10. And here is 5, 12, 13, which is on the list here. 5, 12, 13. So then any multiples of those will also make right triangles. So if I took the 5, 12, 13 and just doubled every side, so 10, 24, 26, that's also going to be a right triangle. So I don't expect you to memorize these or anything, but just something to be aware of. Okay, then the last thing I want to talk about here is called the Pythagorean inequalities theorem. So it says, for any triangle, ABC, where C is the longest side, so if C squared is not equal to A squared plus B squared, so then we said it's not a right triangle. So if C squared is less than A squared plus B squared, then triangle ABC is an acute triangle. means all the angles are less than 90. If c squared is greater than a squared plus b squared, then the triangle is going to be an obtuse triangle. That means that one angle is greater than 90 degrees. Okay, so our final example here. Verify that these segment lengths form a triangle. Then decide if the triangle is acute, right, or obtuse. Okay, so determine if it's a triangle or not. The two smaller sides added together have to be bigger than the third side. So 3 plus 6 has to be greater than 8. So 3 plus 6 is 9, which is greater than 8. So that's true. This does form a triangle. If I had had like 1, 2, and 10, so 1 plus 2 is not greater than 10. So it would be impossible to make a triangle with sides 1, 2, and 10. Impossible to make a triangle. Okay, so it is a triangle. So then C is our longest side. So I'm gonna do a squared plus b squared. Compare that to c squared. So c squared would be 8 squared. A squared plus b squared, so that's 3 squared plus 6 squared. And so 8 squared is 64. 3 squared is 9. 6 squared is 36. 9 plus 36 is 45. Okay, so those are not equal. So c squared does not equal a squared plus b squared. So it's not a right triangle. So it's either acute or obtuse. Okay, so in this case, 64 is greater than 45. So c squared is greater than a squared plus b squared. Okay, so we said if c squared is greater than a squared plus b squared, then it's obtuse. So the answer is that this is an obtuse triangle. Okay. So my substitute will hand out worksheet 9.1. You should use the class work time to get that done and turn it in at the end of class. Several of you missed the test on Tuesday. Either you weren't here at all, or maybe you were here but you did not finish it. I can offer you the option to go to room B135. We have something this semester called the Academic Resource Center, which can be used for test makeups. So if you did not finish your test, I left your test with those teachers in B135. So if you would like to go do the test now, you can do that. If you prefer to wait until another time, you can do that too, in which case you should stay here and get the worksheet done. If you are taking the test, you will need a calculator. You cannot use your phone for that test. So if you need to borrow a calculator, you can get one, get a pass, go to B135. Okay, please use the test time productively, get your work done, and I will see you next Monday.